All right, so welcome everybody. This is just a follow-up presentation I had after the panel discussion on MQTT and the future of interoperability that was hosted by the kind folks over at IIoT World. And I decided to put this just to explain some of the key concepts that were discussed throughout the presentation by myself as well as some of the other panelists. It's really hard to condense all that information in just a brief 1 hour panel discussion where sometimes there's an underlying assumption of some key technical concepts that everybody in the audience may already be aware of. So I just wanted to take the time to fill in the gaps here, and really, the focus I wanted to keep this discussion on was the societal impacts of digital transformation and the broader sense of the industrial Internet of Things. So, just a full disclaimer, none of the material in this presentation is paid for. Nobody has sponsored me. Similarly, just like how I sat in the panel discussion, I was not a sponsored attendee. I freely committed to being a speaker, and all the ideas that I shared then as well as now are freely of my own, so nobody has edited this beforehand. So the what I'd really like to cover today is ultimately defining just what digital transformation is. There's a lot of misconception in what digital transformation is, and sometimes it's conflated to what digitization is, which is completely different. We'll then move into explaining each of the different industrial revolution stages. There are a few, as well as the ones that we will be seeing in the future, and really sharing some three real-world examples of impacts that digital transformation has had. Sometimes these theories are abstract; they can seem ethereal, but I want to help relate it to tangible examples that are real world success stories. And then, of course, you can't really talk about anything IoT with digital transformation related unless you help explain what the differences are with the costing methods and just the general philosophy taken when you look at the, traditional return on investment for IoT projects compared to traditional projects. And now typically, of course, we would have done a Q&A session as part of the discussion, but I'll bring some of the questions that people had during that panel at the end to help tie in some of the concepts as well. So first, we'll start with, Industry 4.0 and beyond, exactly what that means. And really, there are quite a few phases that the Industrial Revolution has undergone and will continue to go. Initially, when we think about manufacturing, we talk a lot about how labor was primarily done with human capital as well as the labor of animals to pull sleds of heavy bits of raw material that were essentially then molded and sculpted by human hands. So the first step was really taking a lot of that hard manual labor and building machinery that can help automate some of that work. That's where we tend to get some of the first stages of industrial revolution, where we have mechanization and other means of essentially doing hard physical labor. It's not quite fully autonomous yet. It's just that these machines still require human manual input, but they take the brunt of the work away from a human or a beast of burden actually doing the work. Then we start shifting slowly into now that we can make things and it doesn't require as much physical work, we can then begin to mass produce them. And this is where concepts like economies of scale kick in, where something can essentially be a commodity and have such a low cost, primarily because it's needed by so many people and you can produce it at such a high rapid scale. And another concept that is really being introduced at this stage is what it means for sustainability and environmental impact to take place in the manufacturing setting. So we start seeing electrical power, assembly lines, conveyor belts kick in. Now that we can make things in mass, we want to further, the next logical progression is removing the human labor as much as possible out of it. So we have the introduction of robotic systems. Great example are FANUC, pick and place, arms, 3 axis, 4 axis, 6 axis robots. And they are essentially at this point, to a very high degree, if not entirely, removing the human labor component completely out of manufacturing. It's not to say that every procedure has completely been removed, removed the necessity of human labor, but to a good degree it has. From there, the Industry 4.0 stage that a lot of folks might have heard of is really the extraction of data, not only from these machines that we've introduced into the factory floor and our means of production, but also how the entire ecosystem from taking a raw material and then transforming it into a finished product and selling and marketing that product and commodity to our customers. We want to take every single data point along that entire life cycle, because that is essentially what will help us best optimize the ways in which we maybe have set up a factory floor, the ways that we task employees with doing certain job responsibilities. And the next logical progression, of course, is now that you have this massive, massive amount of data, you want to be able to take automated decisions, of course, with supplemental human decision making behind the scenes using machinations like machine learning and artificial intelligence. So, a good next step to really tie all that in is the shift from traditional to modern management, because when you are looking at the current state of manufacturing, you have to realize that it is a very rapidly changing environment, not just technologically, but sociologically as well. In order to actually keep pace with all of these rapid changes, people psychologically need to reconcile with what that looks like, on not just an individual basis, on a collective basis, right? You need to understand how humans interact in a group dynamic, because those psychological factors are completely different than how humans interact in a one-on-one setting. And then, of course, you span that even further to a global environment, right? So, a lot of folks have come across traditional project management, which a lot of times it's sort of a misnomer, but for the sake of uh, using words that folks might have come across. Waterfall has been the sequential planning where you are primarily driven and illustrate success by adhering to a completed task. So the measurement of success is not necessarily the end deliverable. That is really not what we're measuring on value, but it is actually on what and how many tasks were completed and were they completed in the allotted time span. The thing that Waterfall does is it maps your return on investment and your overall work and product life cycle to a schedule, instead of seeing what it means to deliver value to what the end customer actually finds useful to solving a particular issue. So there's a very strong upfront investment with the waterfall approach. Um, Basically, all of your planning is done up front, and only after you have completed your 12 management plans, right? You have your communications management plan, where you're essentially really hard coding in what your communication for the project lifecycle is going to be. You are also creating a project charter at the very, very beginning, which is actually spurred and only given birth by folks who are very high up on the organization. So folks that are at the executive level or higher. So that introduces yet another layer of bias where the reality of what the business needs does might not actually align with what folks at the top of the organizational chart think it needs. And there's very frequently we find at an empirical level, it is the norm that there is a disconnect between what executives think the business needs versus what it actually needs. There's a very strong tendency in the waterfall approach to have a um, micromanagement approach where you're really looking to essentially issue out tasks to each and every person and then make sure that each of those folks have done said tasks instead of allowing them and empowering them to freely solve problems as they naturally occur throughout the life cycle of a project. And the crux of the problem is, waterfall relies very strongly on a control manner of not just management, but leadership in general. It does not take into account, or not entirely, but very, very minimally does it ever take into account the psychological dynamics of what in a very controlling and authoritative way of leadership actually has, not just on the success of the project, but their employees and potential impacts on future work that these folks might be doing together or even in other separate teams. Agile is really found, it's a philosophy that truly values transparent levels of communication at every facet of the organization. And that can be quite scary because when you think about being transparent, sometimes it means owning up to inherent flaws. You might have skill gaps, knowledge gaps. You might be wrong. And psychologically, it is not an easy thing for people to naturally admit that they're wrong and then also show initiative to essentially reconcile and do better next time. It's also not the case. People do not naturally know how to help empower other people to do just that, admit their faults, and then help coach them along the way to become a better employee, to learn certain new skills or better improve their communication skills. That is not a natural ability people have. They are capable innately of it, but that does not mean that they are de facto good at doing it. It requires very extensive amount of training, coaching, mentorship, and it's got to be consistent. It's not a one and done. You can't just say, we adhere to the agile philosophy. That is just not how it works. So it's a good shift to then discuss the traditional versus modern ways of costing. I mentioned a little earlier about where with traditional project costing, and it actually scales up to the enterprise level as well. Traditionally, organizations actually look at doing costing by mapping the amount of money they're going to spend based on a schedule, which means in earned value analysis, which is what traditional costing is, you look at spending X amount of dollars in a given period in time, and then you expect to then get a 1.2 increase in return for that amount of dollars that you spent in that given time frame. But sadly, what it does not take into account is it does not take into account that fact that you have to you're not guaranteed to earn a particular set of value at a particular point in time after investing a particular amount of money, right? So traditionally, cost with uh, earned value analysis is based upon how much time you spent on the project, how many tasks you completed on the project. And it ultimately assumes that the deliverables and your outcome is known. But that is not the case when we look at the real life examples of IoT projects. And that's because they follow the path of a software development lifecycle, and software is inherently very complex, and it needs to have a high degree of flexibility. So earned value really is highly deterministic, and it assumes constant value over time, even after the project is completed. Where what happens is once the project is done by, say, a project management office or a dedicated team, that team then gets disbanded, and the maintaining of the value of that project shifts over to the operations side of the business. The operations folks are then expected to maintain a constant value of what was delivered from that project. But that's not necessarily the case when we look at complex projects, especially ones that involve software. The whole thing with earned value is it works very well when you absolutely know what your end deliverable will be. It's typically best used in situations that have a physical, tangible deliverable, aka a house or a car. That is a great way. However, when it comes to the software that is, say, for smart homes, right? When we talk about the systems integration part of what it means to implement a smart home ecosystem, or in the case of smart cars like Teslas, you don't really have the upfront um, deterministic value of what it's going to look like for you to implement this particular software versus that one. It also might be the case that in 3 months that software will be highly valuable, but then afterwards it needs to be decommissioned because it's not going to provide any value whatsoever. It might actually just be the case it's only valuable for 24 hours. And then after 24 hours, it's actually going to cost you a heck of a lot more to maintain. So earned value does not take that into account. It is not particularly flexible means of understanding your earned value in highly complex and rapidly changing environments. So, what does then modern costing utilize in an attempt to actually measure what it's like to, pump money into something, and what can we expect from the from the money that we do invest? So, the way that modern costing actually does is, instead of assuming that the deliverables and values are known, instead, the true value is the information you gain after iterating and doing smaller intervals of um, delivering chunks of a either product or a service to the customer. And what I mean by that is your cost and value are actually are a function of newfound knowledge, and they're only acquired after building, deploying, and gathering customer feedback. So your progress and success is measured in terms of working software to the degree that the customers feel their need to be solved. And it's one of those gray areas where you talk about feelings in the business environment, but it truly it does follow that path. Software can come in a wide variety of flavors, but ultimately you have to solve the customer's issue. And although you might have the perfect platform that can do essentially everything for everybody, that's not a valid way of actually um, not only delivering software, but tracking how much you're spending. So what we look instead in modern costing is something called a burn down chart, where you're instead seeing how much time a person and a group of persons that are working on a particular initiative have spent, and the level of knowledge they've gained over time, and how quickly are they able to then rapidly adapt to meeting the actual needs of the customer. And so instead of, mapping how much money you're going to spend for a given amount of time, really the only thing you can measure is simply how much time was spent on this one iteration and to what degree did the customer feel their problem was solved in that iteration. And you then take that information and you work with it for your next iteration, right? Do we deliver more? Do we deliver less? That is where the key difference lies in with modern costing. And integration into other ecosystems is absolutely at the forefront when it comes to modern costing. Whereas with traditional project costing and even just the whole portfolio management of enterprise, how your solution is going to actually connect with the rest of the business is not given any thought until after you've already delivered your project and you've gotten your lump sum from the customer. That is not how modern projects and modern costing works at all. There is no one giant upfront fee that's taken. It's done in small deliverable small chunks where something is delivered and then information is gathered and you iterate next. There is no giant lump sum taken up front. And it can help, especially when you talk about small businesses, right, or startups that might not have the ability to compete with other vendors who are used to taking X amount of management fees from their potential customers, where a startup can come in and use the agile way of approaching their costing and instead issue invoices to customers that are significantly less in shorter periods of time, and the customer then can feel more confident and trust in this startups or small businesses approach where they can see, bite-sized chunks of value being delivered instead of waiting some ubiquitous amount of time for their problem to be fixed. So, really, what is important then to shift into is discussing how this whole thing overall fits into what digital transformation is about, right? So, we've talked about the phases of the industrial revolutions, where we currently are now with the extraction of data and from all of our robotic uh, pieces of machinery on the shop floor, as well as tracking how users interact with software systems, taking that data and of course, in the upcoming industrial revolution, where utilizing mechanisms like machine learning and AI to make automated decisions that are supplemented by human behavior, we talked about the ways in which traditional and modern projects have been costed and managed, and how people have uh, shifted with how they work now individually and collectively. And really, it's important to highlight what digital transformation is and really define just what it is and how it plays a role in all of this. So really, the short answer is it's a strategy, and it's specifically driven by technology in service of enabling people to become self-sufficient. Now, the thing to get out of the way here is it does not mean that you are removing people. That is a common misconception that, oh, well, digital transformation means you just lay off your entire workforce as much as possible, you reduce your headcount, you save on cost because automation will fix everything. And that is simply not the case. Such a great example of this is when you install six-axis robots. That does not automatically mean that your entire plant floor does not require humans to be employed. That is just silly at best. You absolutely need people there. They just now take on a different set of responsibilities and and the responsibilities require higher levels of complex skills. So now you have to have folks, with a control systems background that can understand not just how electricity and electronics work, but also how software works, because those machines still need to be maintained. You still need to have somebody that is mechanically inclined to understand how all these gears work and potentially can fail, and you need to service those every X amount of intervals. That is absolutely not something you can ever remove. So this misconception that digital transformation is just remove people, it's silly. Really, what it boils down to is embracing that you need to continually educate your workforce, top down, bottom up, and laterally, because the ways in which their day-to-day responsibilities will shift are very dramatic. It's a paradigm shift in the old approach, which is here are your tasks, here are your responsibilities, here's your fiefdom of work, and you will only operate in this manner. But that is not the case with the reality today of the plant floor and the ways in which the future, in the next logical conclusion of the future, when we talk about using mechanizations like machine learning and AI to make automated decisions, you need people to understand the ramifications of these systems and to implement these systems as well as to maintain them. Just because something makes automated decisions in the background does not mean it will be able to forever run without any service intervals. So that's a very key point to know. Um, and really, it's a strategy, though, that empowers organizations to leverage technology to improve their processes, their products, and their service end to end. Um, what I mean by that is you're enabling the integration of all digital technology, where you fundamentally change how the business operates and delivers value to its customers, right? You are essentially realizing that it's not your physical products or your tangible services in other commodities that are where your value lies. You're actually a data company, and it's the extraction of data at every level of your business that is actually making you more valuable. Because without data, then you have no evidence to say um, what areas of your business you need to improve on. You're essentially going off a hunch, and that is not a scientific way of operating and being competitive, especially now that businesses have to compete on a global scale. Somebody that um, knows for sure the areas in which they have faults in and can correlate those issues with other parts of their business is going to be successful. Whereas one that does not have any insight into how one area of the business impacts the other with verifiable evidence in real time and historically, they're totally going to be at a disadvantage. But specifically with digital transformation, though, it requires a vendor neutral, solution stack agnostic, and technology centric approach. Again, this does not mean that we remove people from the way that we operate, but it specifically means that in order for you to compete and be viable as a business, not just for today, but for tomorrow, you need to be able to interoperate not just with the machine from a machine to machine level, but also from a software to software level. It means embracing open standards. It means embracing transparency. It means embracing mutual collaboration. And again, this is a massive paradigm shift, right? Um, where digital transformation is not just a project or a series of projects, right? This is oftentimes why folks get digital transformation wrong. It is not just good enough to say, we're agile, we're doing this agile thing. And that does not make you a agile organization, nor does it make you a digitally transformed organization. Again, it's not about slashing workforce headcount, under this false pipe dream that automatically things will be automated. It's not a cheap shortcut to customer success by, again, just buying more robots, especially because not every manufacturing environment necessarily needs more robots, or if they do, they don't need the same exact kind of robot. It's also not a proprietary monolithic ecosystem. In the software space for manufacturers, this traditionally has been the enterprise resource planning platform that's often pitched by um, two big vendors, SAP and Oracle, that have sold customers this bill of goods that says, ERP will integrate the business for you. When in reality, what it does is it creates a closed loop ecosystem that will integrate everything into ERP, and the ERP layer does not talk to other facets of your business. So it will integrate into your ERP layer, but your ERP layer is not the end all be all of your business. The key to embracing interoperability is to realize that proprietized software and hardware is not the way. And furthermore, there is not a one size fits all solution, application, tool, or platform. That is never been the case, I would argue, and we have seen it from the decades that ERP has been around. Customers have always wanted a integrated business. They don't necessarily have the technical wherewithal to understand what that truly means. So, frankly, they've been very ripe to be sold this bill of goods that if you just integrate your ERP into everything by making a proprietary closed feedback loop just to the ERP, then that automatically makes you quote unquote integrated, but it does not. Um, and this last bit I think is ever more important, where digital transformation is not a choice, right? The business of the future does not have a choice but to digitally transform. Supply chains absolutely will require that you be a digitally transformed organization to connect to a digital supply chain where you can see what other vendors are doing with their supply chain. And similarly, people want to know what you're doing with your supply chain. So this concept, right, of trust is equally important here psychologically, because you can't have this environment where you're waiting, right, for somebody else to make the first move and then simply extract the knowledge that they have gathered from their hard work and their efforts, and never then give back. That is not how it works. And so you must be able to not only give information, but it's not just for a time period, it is for the foreseeable future that you are continually sharing information about yourself. And, this is where concepts like the network effect kick in, where it's not that you need every vendor ever to be instantly connected at one time. In fact, what we see is you only need about 10-15% of a industry to be connected to a digital supply chain, in this case, for everybody else to see not just the value in it, but to then start demanding other folks to also operate in this manner. This being interoperability based on open standards, vendor neutral, solution stack agnostic, technology centric approach. So we talked a little bit about what digital transformation is not, right? Reducing headcount. Uh, it's absolutely not a choice. And equally important is to highlight some of the things that what it takes to actually digitally transform an organization. So the four principles really that are the foundation of digital transformation are the technology ecosystem in which you operate in must be one that is uh, de facto report by exception. Of course, the reason why this is when you have more and more data being streamed, not just from smart devices, but inputs from humans going into the software ecosystem, you don't want to just simply gather every single point in time when you have more and more things ever connected to your network. You need to have something that will only share information with you when it has changed. So whenever there's a delta, that's when you want to care about it. Open architecture here again means, you don't buy into the Rockwell solution stack thinking that it will just automatically solve all your problems, because the real issue is Rockwell does not make all types of hardware for every possible manufacturing scenario. So of course you're going to be left with dealing with other vendors' hardware, and you need all this hardware to talk with each other. So you cannot adopt and give into proprietized standards, because it only will serve to your detriment. It needs to be lightweight, where what gets transmitted over the wire is not this, infinite amount of infinitely large packet size. And it needs to be edge driven, which means the smart thing is telling you about itself rather than you trying to tell a smart thing what it should tell you. The smart thing is the one that's communicating out, and it needs to be that way, because the closer you get to the plant floor reality, again, in this case being the smart devices, that will be the most accurate depiction of what's going on a moment to moment basis of your business, not a layer of bias that somebody is telling a device what it should be telling you. No, you want the device to tell you everything about itself, and then you apply context after it tells everything about itself. This next one might shock some folks, but digitally transforming truly means you have to have a conscious, consistent, and meaningful engagement with open source communities. We've talked about open standards, predominantly in the manufacturing space. It's MQTT, and you just can't expect this, um, whether it be a open tool, a platform, or really any other open source software, to just instantly work and you never giving feedback into that community, when inevitably custom issues are going to arise that are unique just to you, and you need to be able to share that feedback with others. Otherwise, the ecosystem itself will never be improved. This is where, when we're talking about the agile way of working and shifting into doing business, transparency and a willingness to give and take is very important. The success of these communities, likewise, will also depend not only on the commercial success of the tool, but they depend on customer feedback so that they can keep making an ever better product. They're inherently incentivized by nature to want to get your feedback, so that um, otherwise, they will fail to be relevant. So it's not like, oh, well, if I just, you know, task some employees to collaborate in this open source community, I'm wasting precious business hours. I'm not getting a tangible return on investment. Why should I waste employee time into dealing with an open source community? But that's a very short-sighted manner of operating, because you the tool that you're relying on in this greater method of interoperability simply cannot exist right? The basis of all this is that none of this can ever exist unless there are open source communities. And in order for those open source communities to continue be existing and be successful at what they do, they need feedback from users like yourself. And again, you're no longer a commodities provider. You are now a data company. Um, and one of the biggest things that arises out of this is there's a deliberate effort to reduce technical debt. What do I mean by this, right? A lot of folks have legacy systems and infrastructure in place, many of which are proprietary by nature. And what that means is it inherently stagnates your ability to scale and to change as not just economic times change, but what you see in your the needs of the customers of which you're essentially doing business with change, whether it be that the thing you made once before does not suit their and fix their business case anymore, or if there's another um, organization that comes in with a disruptive way of uh, doing work, right? Whether it be a product or a service, really all of that is only able to be managed if you have a deliberate effort to integrate um, your systems at the forefront instead of having integration be a back burner uh, uh, point where you say outsource your work to a vendor, and they operate in a traditional manner. They take a lump sum at the beginning, and then once they hand the solution off to you, it's totally hands off afterwards, and you're basically left to your own devices. Well, that's not how a digitally transformed organization operates. And we see this with companies like Amazon, where they actually invest a lot in um, pushing a lot of their technology out open to the for the public to use. And it's great because there's this feedback loop of not only do people get to use it for their own organization to help themselves, but by doing so, they again contribute to um, making it even better for others. And it's a mutual give and take. It's not a unilateral uh, way of interacting and being. Um, this is also where, disruptive and transformative leadership comes into play. Traditionally, leaders, whether at the board level or executive level or C-level, they've usually been folks who have a very strong business, administrative and finance and accounting background. But this is the paradigm shift where instead the norm is shifting, and I think rightly so, to leadership that comes with a very deep level of technical expertise. Folks who have worked from the shop floor, who have been in scientific roles, whether they be an engineer or a researcher, and they pick up a lot of the business acumen as they progress throughout the organization and along the way. And this is primarily, again, because this is a rapidly evolving uh, way of how not just manufacturing, but overall industry as a whole is. You can't, plan for everything up front and then stick to the plan at every step of the way. You prioritize flexibility and adaptability, and then and only then can you be successful. So this great photo here, what does digital transformation do for you, right? So I have a little note here on the side too that I wanted to cover. When we talk about the ecosystem and integration being at the forefront, conscious effort being put in place to integrating all of your data systems. It's important you do that rather than an afterthought because you can't get any insights from these systems unless you do this. So, important to cover here is the difference in definition between digitization and digital transformation, right? So digitization is the act of shifting all physical recordings of events to electronic means. And the reason why we do that is because human manual input is very prone to error, like 60, 70% prone to error. So the data that most organizations currently have, is total junk. It might be relevant and accurate for one or two individuals for a specific point in time, but as far as the bigger picture of how it relates to the organization, it makes absolutely no sense. And so concepts like the unified namespace, where essentially what it does is help correlate and normalize events in service to digitally represent the business, or we have a true digital twin of the organization rather than just a haphazard mix of data that has been incorrectly captured and then using that data to then make incorrect business decisions. Um, this is where you get into the territory of a truly interoperable tech stack. This is how you're able to have a true real-time supply chain with real-time information in a very high level and at a very fine granular level. The unified namespace is what enables the interoperability that we've talked about before with open standards like MQTT and its companion spec Sparkplug. So we talked a little bit about this before. What exactly does digital transformation require of you? Absolutely vendor neutral, solution stack agnostic, and technology first and people centric. But the really what I want people to get out of this uh, point is a organization needs to be values driven. And this is what's really going to make or break a lot of organizations because it's one thing to simply just exist for the sake of profit. Inherently businesses and organizations want to turn a profit because that is ultimately what allows them to continue operating. But if the sole means to the end is just generating more profit, you will not be around to do business because you then do not have an incentive to help better open source communities, which then will not allow you to create interoperable um, technology in your organization, which will then further drive you down the path of increased technical debt, which will not allow you to scale, which is absolutely going to solidify your demise as a business. And these values are not just top down. It means that these values are coming from top down, bottom up, and laterally. This is a conscious effort to engage employees at every point at every layer of the organization. Um, this is where psychological concepts come into play, right? Where we talk about Parnell's iron law of bureaucracy, where we talk about the Tuckman model of group development and how there's stages that humans go through when they are put into a situation where they have to collaborate with other folks via a group, and the phases that the Tuckman model shows, it's not um, sequential. It's not like they jump from one to the other. In fact, and it's not guaranteed that folks make it throughout all six stages. Um, and you need to also be cognizant of what happens after uh, a group of people is then split up, right? Psychologically, how do those folks engage when stress inevitably comes up, or a difficult personality is part of the group, and unfortunately, it's a stakeholder they have to work with. But say, that particular individual introduces stress, and the threat what's the threshold of stress that individually and collectively the group of people are able to tolerate, and what does that do? These are concrete scientific frameworks that are codified by neuroscience, and we know quite a lot about this. This isn't just some pie in the sky type of information, you know, where the age-old adage of, psychology and engineering do not mix. They absolutely do. It is why we have safety systems like seatbelts and airbags and other layers of protocols and processes that help make air flight very safe as it is. To piggyback on this, we talked about a mutual collaboration, values driven. It specifically means the end of the embrace, extend, extinguish framework. Uh, this is something that, was originally fa- founded by Microsoft, but they're not the only ones that do this. And essentially, it's a very manipulative way of existing where you pretend to embrace a open standard and open source community, and then you do this under the pretenses that you're going to help them by contributing some of your resources into making it better. But it's only because the means are justifying the ends, which is you're trying to eradicate this open bit of technology, or open platform, because it is in fact posing a threat to your business. And um, instead of embracing the innovation and welcoming the change, you are instead trying to thwart it. And so, again, this is where other psychological concepts come into play, where truly, if a lot of these tech giants are operating in this disingenuous and not good faith manner, where they're trying to squash innovation, then I would argue, really, does the current system of economics actually work? Where we talk a lot about free market capitalism, and is it truly free when clearly we have seen time and time again these folks are actively squashing open source communities, open platforms, uh, in the name of uh, keeping market dominance and market share. I would argue that it is, in fact, a terrible way to operate a economy. But um, that's not really the focus of this presentation. But it is very important to have critical discourse about this, because we do have empirical evidence to show that it is not as effective as people often misconceive it to be. Equally important here is that IT is a service organization. It is not the single voice in the business. What do I mean here? Folks that are familiar with cybersecurity of the plant floor often talk about the Purdue model, where essentially you have a DMZ and you're trying to section off layers of your of the networks in which your machines communicate over, and totally seclude them from the rest of your business. But yet you're still not quite embracing the open standards where only the machines and smart things are telling you about them, because you're still trying to tunnel back into them and tell the smart machines what they should be telling you about themselves, which assumes that you know exactly what you need at what point in time, instead of allowing the data to tell you that. So, it means the death of the Purdue model of plant floor cybersecurity. And while cybersecurity is absolutely important, their voice actually counts for significantly less and should not be a barrier to innovation. When we talk about report by exception, a lot of the threats that innately come into play when you are tunneling insecurely back and forth between your shop floor devices ultimately result because of the Purdue model. And so that is, no longer viable in a modern, digitally transformed organization. And, systems integrators, furthermore, um, they operate on a project by project basis, right? Instead of using the age-old philosophy of go long and deep, where you essentially create more and more proprietary solutions to keep the customer beholden to you. Instead, you're teaching other people now to do what you do. And it is a valid business model because you are, in fact, still going to have the need to train new folks that come in on how to do what it is that you do from your customers. And inevitably, those customers are going to also come back to you with other problems they have that they need fixing. And so it's not like you're going to somehow find yourself dried up out of capital and cash, because it's just not empirically true. So some of the trends, we've kind of talked a lot about what societally digital transformation will have and some of the trends that we might be seeing, but we'll dive a little bit further into this point. So when we talk about jobs, right, here we have what's commonly known as the automation stack. Every manufacturer on the planet has this same stack. Now, as far as what they use for their stack, that will be different. But this is essentially what their entire information technology stack looks like, right? What does this mean? It specifically means this notion that you can simply exclusively specialize at just one layer of the stack is no longer feasible. You have to be, if not an expert at each layer, you have to be proficient in the language of each layer in the stack. Now, what that does mean for you, though, is there will, in fact, be a higher level, a higher paying job because inherently it requires more complex technical know-how from the individual. And very few organizations on the entire planet can actually even make a claim that they're digitally transformed in the first place. I think the actual empirical number is a dozen or less than a dozen organizations on the entire planet can even claim this. So it is good for the individual employee because there is a very big need, huge need for folks that can do this type of work. A great example is for retrofitting a either a household or even a commercial building to when we talk about 4.0 systems integrators, things like integrating the fire alarm and security systems to have smart capabilities. That's huge. Many buildings do not actually have that ability, and there are even newer buildings that are being built that do not have that smart integration, and that is a huge job market, and not many uh, legacy integrators are able to even do that kind of work. Yeah, and extending another talking about the automation stack, extending event-driven architecture, which is what this is actually something that creates jobs because now you need data analysts. You also need more solutions architects to manage this infrastructure who um, have a know-how in the software side of things, but also you have a bigger need for controls engineers who have a deep understanding of not just the hardware, but the protocols, especially the open protocols that and need to be used in order to make a successful, truly interoperable, digitally transformed organization. Um, with high complexity, the other unintended consequence of that is it can also mean a high barrier to entry for certain jobs. But it does also mean long-term job security because the not just where we are currently in Industry 4.0, but the Industry 5.0 stage in the Industrial Revolution will only further drive this need for folks that essentially have a software engineering background and a mechanical engineering background, a chemical engineering background, and an electrical engineering background, kind of all packaged and bundled up into one. Um, it also means that because there's legacy systems, that the inherent complexity involved with integrating those into smart ecosystems is still very much a real need. And so, that's not going away. Um, Interestingly enough, let me see if it's on the other slide. Yes, it is. This also means that candidates instead will seek you out as an organization that they would want to work with. This is quite different from what we're used to seeing before, where traditionally organizations are used to people sort of applying and sending a job application. Then you sort of hear back and see where that comes from. And you have your pick of the litter, so to speak, of what employees you want. But being that more and more people are privy to what it takes to be a digitally transformed organization and the needs of getting an organization to that stage, it means that you are an organization that's values driven. So yes, you make profit because you need to exist, and profit is what's seen as a just one facet of what it means to be a successful business. But really, candidates are now going to start seeking you out based on what values you have outside of just generating profit, right? As part of your initiative to connect, collect, store, analyze all of this information, all of this data, are you taking, conscious business decisions into reducing environmental impact? Are you generating uh, social social mobility, social upward mobility by creating community spaces and investing in schools or health programs for the area that not only will attract people to you, but align with your organization's values, right? And what do I mean by values? I mean very clearly defined values like humility, servant leadership, dignity. These are very explicit values, and not many organizations truly can say they operate by a set of values. And people, especially in the information age now, will be able to quickly pick up, you know, do you, if say you have certain values, do you actually mean that? Are you actually living in that, or is this just something that you're saying but not actually doing? Um, Interestingly enough, with the rise of VR and AR, there's been quite a bit of conversation about what it means to then be a, say PLC technician of the future or an electrician of the future, a machinist of the future. Well, with VR and AR, you can have folks who are remote actually troubleshoot machinery where they're able to see various schematics and pinpoint issues because they have access to real-time and historical information on the overall plant, but specifically for that particular machine when a specific uh, process was running that was making a specific product at this specific point in time. And to have folks that can do that type of thing is going to be critical because you're competing at a global scale, right? So your workforce might not necessarily be just coming from your local municipality. It could be folks that have a talent that are elsewhere, but you need to enable them, right? And empower them to be able to do this type of work. And that can only happen with an organization that's digitally transformed. This is probably one of my favorite ones, beyond the scope of open source software. Hardware is a huge, huge point in here because when we talk about especially electronic systems, there's a lot of particularly chips in semiconductor platforms. There's not really any giants that make truly open access semiconductor platforms where they make chips that have similar capabilities for extended periods of time. Oftentimes, what you actually see is semiconductor manufacturers will make a very limited supply of chips, and that lifespan will also be short for that product line, and then they'll kind of cut it off as a part of planned obsolescence in order to drive the further, selling of other semiconductor products, despite it not necessarily being the case that you need those. So, what does it mean to have an open access semiconductor platform, right? Well, I envision something like where you're able to put in a set of specifications, just like how when you are approaching a hardware vendor that sells a gateway for integrating your legacy machinery, it needs to follow the four principles of report by exception, open architecture, uh, lightweight, right? These are things that inherently can also be applied to an open access semiconductor platform where a customer can punch in these specifications to get a semiconductor chip platform that can fabricate these chips to meet these open standards. And it's going to be really exciting to see this because, again, as we talk about interoperability more and more, this is going to be critical. You can't run electronic systems without semiconductors, and you can't have interoperability with proprietary solutions or products. Therefore, you have to have open access semiconductor platforms. And I think we will start seeing a lot of this, even if it might be slow and painful. And inevitably, it is a necessity. And where we've seen this actually be successful is organizations like Amazon that actually make their own hardware because they have seen the slow uh, adaptation to change by traditional monolithic giant semiconductor or manufacturers like TSMC, for example. All right. So, we've talked a lot about the jobs and business and industrial settings and how they've been impacted, but what does this mean for, our social lives, whether individually or collectively, right? One of the biggest areas you're going to see is specifically with schools. They've already felt this disruption, but schools will need to absolutely embrace digital transformation because if they don't, then inherently they're limiting the students' career upward mobility. Um, and inherently, if somebody does not have the, economic means to help their life circumstances, then typically what that means is a lack of social diversity. And you want more socially diverse people, and you want people that are empowered to solve their own problems, particularly because it actually tends to be more efficient when you allow people to self-organize in a decentralized manner. A great analogy to this is the reality of the shop floor comes from the smart device on the plant floor. It does not come from a supervisor or a manager telling the smart machine what it should be telling you. That is introducing a level of bias that further removes you from the reality of your business and what it actually needs. And um, really, what schools and teachers in particular need to do is essentially teaching self-sufficiency. It's exceptionally challenging because there's a lot of misconceptions people have where they think, oh, with electronics, you can just do everything in virtual school and you never have a need to meet people in real life. And what that actually leads to, from a neuroscience perspective, again, which we know quite a bit about from social psychology research and neuroscience, is if you exclusively just utilize this VR method of teaching and interaction, it actually leads to a very high level of antisocial behaviors. And we actually want the complete opposite, which is pro-social behaviors. And this is where schools greatly come to play because they, instead of just sort of being a middleman, so to speak. They actually can provide the necessary contextualization for the bits of information that students are uh, inherently learning on their own, since with everybody having access to all this information, the ability for a student to outpace the the teacher as well as the particular curriculum that a school might have in place is actually quite common. And in fact, most students do just that, where they are really disengaged from the school because they have access to all this information outside, and the curriculum still has not kept up with what's truly important for today's, you know, to today's individual and today's worker. Equally, I think interesting here is when we talk about citizen science, which is this very interesting new business model where essentially you have um, just folks that might not have a strong level of technical competency, but they can actually interact with these software systems and input information uh, into these systems that can then enable a platform that shares a wealth of information to everybody else. Here's a perfect example of this, right? When we talk about something that folks might take for granted, like an auto repair shop, how is it that people are making decisions to choose one auto repair shop versus another? Well, currently, a lot of the way that's done is folks just use word of mouth, which is a way of making business referrals, but there's really no empirical evidence there showing, this shop in particular can do a better job than this other shop. And what citizen science would come in and say is clearly there's a need for people to have empirical evidence to quantify, how many certain types of jobs has this one shop done over another, and what has been the level of satisfaction of this shop versus another, outside of just social media reviews that people leave, right? Can we see that they've done 10 brake jobs in the past 5 years, and in that period of time, they've had terrible reviews for brake jobs, or they might have had mediocre reviews, but this other business over here has done, 100 brake jobs just in the last year alone, and they've had a very high level of customer satisfaction. So the next time you bring a car in for a brake job, right, do you go with one that has more expertise or less, right? This is where a small business can come into play and create some of these software solutions, all again based on the same principle as before of interoperability and values driven, because it takes somebody that cares enough about not just the consumer but something they have personally witnessed in their own lives to then want to take action and remedy and help others also benefit from. Data inherently also has to flow through some type of infrastructure. It's hard to be interoperable and to talk about, this sharing and this transparent, open ecosystem of data, where and there are in fact many private owners. And especially in free market capitalism, the long withstanding debate has been not only that the market will regulate itself, but that owners, private owners, capitalists, right, take more risk than the laborer, because the capitalist has to have purchased the machinery and the working capital, and that's a far bigger investment than the employees, say, who might lose their job and doesn't have to worry about paying off the debts on those bits of machinery, and all they have to do is just learn how to use those bits of machinery that the capitalist has purchased. But that's a fifth grade way of looking at it, because really the interdependencies and relationships between the labor and capital is far more complex. It is not that one is more important than the other, the capitalist or the laborer. It's actually quite the opposite. The capitalist is equally as useless and irrelevant if they do not have labor to use their machines. And likewise, so is a labor if there is no infrastructure. But in this case, they can actually create their own infrastructure by platforms and business ideas like citizen science to solve personal life problems. And people will gladly, in fact, pay to have this type of information openly and readily accessible. Nonprofits have been doing this for quite a while. Um, I can't remember their name off the top of my head, but they publish these great dashboards for incarceration rates, and you can see heat maps of what kinds of arrests and what the type of crime was in a specific area. And people want to know, and that's a empirical way of doing advocacy. When we talk to lawmakers in your areas or lobbyists. So that relationship, as it was previously understood, where the capitalists were taking more of a risk, it just isn't true. And this really then begs the question of, is it truly capable, or is it possible to have this interoperable and digitally transformed organization with private ownership, not just of the data, but also of the pipelines through which that data flows through? And what will it actually look like, instead to have a public way, if we want to label it that, of making this infrastructure public? The current model, similarly, of how we regulate utilities, electric, oil, and gas, is far from perfect. But I think it is a step in the right direction. My own personal belief that we do treat these data pipelines and this data infrastructure as just that, a public utility, because it is a basic need that everybody relies on. And it does not serve in the best interest, and nor are these private organizations incentivized to make the infrastructure better if they exclusively outright privately own it, right? Talking about, again, uh, an analogy is the open source communities, where they are inherently incentivized to continue adapting and changing and making things better, because otherwise they will remain irrelevant. It also means revamping ESG frameworks, right? For those that don't know, I'm talking about and the European Union's framework on environmental, sustainable, and governance frameworks. A lot of these frameworks are total hogwash, if not all of them, because they don't use the proper scientific language, and proper scientific frameworks. They do not have a basing in empirical studies at all, and that's why you see so many of these articles talking again and again why investors who have tried to use current ESG frameworks have absolutely lost all of all of their money and all of their hair on their head, because they're inherently using flawed frameworks that just simply do not understand what it means uh, to invest to invest and have an ESG conscious investment effort. So this is, again, some of the scientific principles we've talked about in neuroscience and in social psychology come into play, right? Tuckman group model, stress individually and collectively, difficult personalities and how people respond, and various stress thresholds. Um, this is all valid, empirically backed, clinically understood, um, measurable frameworks that the scientific field has known about for quite some time. And it's time that we take those measurable ways of operating and apply it to ESG frameworks. I don't believe ESG is irrelevant or silly or detrimental to innovation. Instead, I strongly believe in, and we can empirically see that these frameworks are just not useful because they don't actually have any backing in anything scientific. We can't just outright say ESG is bad, but what we can say is that the current way that the European Union and other folks do ESG is terrible because it has no legitimate grounding in science. Another example of a citizen science project actually is going to be very interesting to see is folks that do search and rescue missions for animals or try to have rehabilitation centers for animals, whether they be, birds or bears. They attach GPS units to the animals in order to track, GIS type data, and then they can conduct research that way. But it's a very manual process for them to reconcile all this information and then make, empirical statements for what behaviors they have seen these animals exhibit. And this is a great example of where you can use and leverage open standards like MQTT to publish this GIS data that folks are already capturing from various wildlife to then allow other people to see just what is going on in their uh, physical ecosystem. Again, helping them better integrate not just in the electronic, manufacturing part of their lives, but the natural biological facet of what it means to exist as well. It's equally important that people have access to this type of information. So we talked a little bit about impact of and trends with government, specifically in ESG. We talked about status quo, pursuit for market dominance, transparency and network effect, as well as a tipping point, right, where you don't need everybody to be on board, just 10, 15%. Um, but it's important that as we create these integrated information and data highways, there is inherently a great benefit of reducing corruption when you can empirically track and see exactly and correlate, and then also uh, pinpoint a causal effect for a decision that was made, and you have the empirical evidence to show that, hey, your decision had this particular impact and effect. One of the things I wanted to really highlight here is, Microsoft patenting the OPC UA digital thread approach to using MQTT, right? The OPC UA pub sub, Microsoft patented that. What we need to have essentially a complete overhaul of patent law because it does not empower and enable a truly interoperable, not just manufacturing environment, but a human ecosystem, so to speak. If we have these organizations fighting to continue maintaining the status quo and privatizing and proprietizing everything. So in an attempt to squash innovation, as we talked about before, with the Embrace, Extend, Extinguish framework that is still very active to this day, as we can see from this headline. Um, Equally of important, I think, here is when we talk about measuring ecological environmental uh, data, we have to remember that what we measure there needs to be contextualized to social events. A lot of folks forget that technological innovation happened because um, there's a clear human need, and clearly humans were behaving in a certain way that demanded this innovation to occur. And how it occurs sometimes, by happenstance, aka accidents, or sometimes a deliberate effort is a totally different thing. But you need to understand that, while it's good to measure what's occurring in your environment, you need to contextualize this data to social events. So a lot of the current conversations around methods of transportation with electric vehicles, folks, you know, it's often sell consumers that electric vehicles will auto-magically, save and fix the environment, where that's just grossly overstated. Really, when we take a look at the history of transportation, people built ways to live, and then the transportation methods helped them get from the things that they've built. So it's not that the, train came first and then people figured out how to live. No, it's in fact that people planned where they wanted to live first, and then this technology came about in order to help them, close the gap in getting from point A to point B. And it's important to then remember that when it came to, uh, urban planning, where you start to see a lot of, you know, suburban homes, single family homes that have little to non-existent public transportation, that was a deliberate, socially driven series of events that led to the physical environmental design of homes being that way. And it's important that you understand the social um, uh, underlying facets first before making environmental and ecological conclusions about what you're measuring in the environment, right? You have that's very important in this particular case with when we talk about trends in government and the environment. There's quite a bit of folks who do ecological measurements, but they neglect, you know, what was the root cause that ultimately led to the data that you're currently seeing in the environment, right? It's not like it was just this independent, totally, you know, free factor thing that just happened on its own. No, it was a social event occurred that then drove to a environmental consequence. And then, lastly but not least, it's interesting, right? When we talk about automation and efficiency and optimization, it's important to ask, to what end are we pursuing this optimization, right? Are we doing this to just continue producing more and more and more ad infinitum? Or are we producing to a certain extent and then implementing, uh, fail fail safes, like doing conscious and deliberate and long-term fasting means, where we do not produce at all or do not produce anything in order to allow the environment to recoup and heal. So this paradox of how efficient are we going to get, and can we be too efficient, are actually very important topics to have. And to what ends are we actually increasing efficiency? Is it just so we can continue consuming more, or is it because we want to, in fact, actually consume less and then plan for long periods of where we don't have to consume anything at all? Because we put in the legwork to make high quality things that will last and enable us to allow the environment for which we cohabitate to naturally heal. And again, this is where medical science and other fields of science outside of just engineering come into play where, medical science clearly shows that fasting is actually a great and viable way for cell regeneration and long-term health. And equally, you can apply that to manufacturing. So again, this is where, that we show the automation stack where you need to be proficient in every layer of that stack, but you also need to have a deep, deep mastery of social psychology and neuroscience. You can't just, exclusively be an engineer, and I would argue that's never been the case, but instead something that, an ideal that people have sort of bought into. So really at this point, we're getting to the end here. And I just wanted to wrap it up with a couple of points. So, right, in summary, the human eye can't see everything. This is where we have machine learning and AI. As you collect more and more data, you can't tell the smart thing what it is that you think it should be telling you. Instead, you need to use mathematical models, um, supplemented by human decision in order to make truly empirical and efficient business decisions. So, furthermore, today the employee and the leaders of the future need not just a deep technical mastery, but truly a mastery of clinical evidence-based neuroscience and psychology, not just platitudes. It's so important that these folks who are in charge of leading digital transformation initiatives are quite competent in these fields. Otherwise, it will only serve to the detriment of everybody, including the leaders themselves. Pro-social behavior, right? What do I mean by this? Mutual collaboration, um, a willingness to sacrifice, a willingness um, to take the other person into account and how your decisions will impact them are of great importance. And the mutual benefit instead of just the private sole individual benefit are equally important. And again, this is back to vying back to the whole digital transformation is not optional because digital transformation cannot possibly be successful without pro-social behavior by leadership and the rest of the organization. And probably one of the most interesting facets, I think, is what before, as we were looking at the other industrial revolution stages, humans really have been fighting for quite some time to essentially win against nature for survival and compete for survival. But in our current automated way of life, we have, tractor trailers that deliver us food. So hunting has not been part of our psyche for many, many, many years. Uh, Furthermore, the ways in which we find mates today is no longer a, battle to the death, as it were, for our primate ancestors. And similarly, a lot of, natural phenomena that otherwise would wipe out human life have been conquered to a very great degree. We have people that have various physical or developmental disabilities that can still leave good quality uh, lives. And that just would not be the case if we look back to our ancestors and just out in the natural world with wild animals that, they primarily exist for passing on their genes, but humans, as we have had things like industrial agriculture, survival is really not the primary or sole driving force anymore. And what this means at a very deep fundamental level is humans need to psychologically reconcile with this reality, right? The need to be a hunter and gatherer is just not has not been part of our DNA. And not to say that it's not part of our current biological makeup, but it means that, psychologically, it is really not part of our reality anymore. So what does that mean, right? It means we can have a fulfilling life based on conscious decisions. And really what's going to drive what quality of life somebody has is the individual decisions they make, as well as the collective decisions that people are empowered to make by social institutions like government, right? So this is such an important bit of information that we're reviewing here, and digital transformation will only serve to best reconcile and speed up this process. So I want to thank everybody for sticking around for the presentation at this point. You know, personally, when I was going through school and other engineering jobs I've held, um, I've never really bought into this idea that, you're supposed to just keep everything the same. I mean, quite literally, in our engineering school, and I know not just myself, other engineers I've worked with, we're literally taught one of the first things we're taught is something called how to do a design of experiments, where we systematically change a factor and see how it impacts the rest of the system. Change is fundamentally built into how not just manufacturers work, but the literal human condition is nothing is permanent except change. And this quote by I'm not even going to say the name, I'm going to butcher it, but it's so important. It's so important that we recognize you can't expect manufacturing to just be this place that is, forever the same. And, like it or not, nature has a way of really pushing forward that change. And, one of the ways that we see is people, socially congregating and making these organizations with disruptive and transformative leadership that are blowing away the once held institutions like Microsoft and others. And again, with Charles Darwin, it's not who is the most physically strong, um, nor the smartest. It's actually the ones that are most adept at interacting with each other to propel that change forward. So this is where, basically what he's saying is pro-social behavior is the gold standard, and that's what actually leads to determining which species will survive or not. And with that, we'll call it a night. So thanks everybody. Stay tuned for the next video and see you at the next one.